Hello, everyone. If you think you are on the webinar, Can We Afford to Ignore Solar Geoengineering? You're in the right place. Good morning or good afternoon, depending on where you are. My name is Dan Wicklum. I'm the CEO of the Transition Accelerator. And today, for this topic, we have two guests that I'm actually very excited to have on the webinar. I think I'm going to learn a lot. And that is David Keith. He's a professor and founding faculty director of the Climate Systems Engineering Institute at the University of Chicago, and Lisa Dilling, who is the associate chief scientist of the U.S. Environmental Defense Fund. So welcome, David and Lisa.
Good to be here.
Thank you so much.
Look, as always, we've got a little bit of housekeeping here, and then we're going to jump right into this. So first of all, I would say we're developing quite a good tradition as from my perspective of the audience being super engaged in these webinars. So two things: please engage in the chat. Go into the online chat associated with this webinar. And one thing we're asking people to do now is introduce themselves. Like, who the heck are you? Who do you work for? Before you get into a chat back and forth, but really encouraging the chat. So please introduce yourself in the chat. And separately, we really want Q's and A's. So I'm going to be pushing you several times, folks, during the course of the webinar to come up with your tough questions for Lisa and David. And we are going to reserve about half of our hour and 15 minutes that we have to actually talk about your questions. So you're a really big part of this webinar. The other thing that we really find with the questions is we're really taking the temperature on people about the actual issue itself. So even if we don't get to answering your question that you put into the Q&A, we keep track of all of them. And on almost all of our files here at the Transition Accelerator that we think are important enough to have a webinar on, there's usually next steps. And the questions that you put into the Q&A really help us scope out a next steps on the file. What's our program of work? How could we help advance it or strategically? So engage in the chat. Introduce yourself, and please keep the questions coming. Second thing that we always do is take the time to do what most people call land acknowledgement. At the Accelerator, we really try to challenge ourselves to think through deeply what we do and how we do it, and not just do things to sort of check the box. So for this land acknowledgement, I'm not going to talk about the individual peoples that happen to live for an awful long time where I live, which is in Treaty 7 land in Calgary. But I'll just ask people to reflect for a moment that no matter where you are in North America, for hundreds of generations, there were families living here. And those families had babies, they made unions and marriages, they raised children, they grieved the loss of their elderly, they made political and trading alliances. And then the world changed dramatically around these people in sometimes ways that was not very fair and not very kind. And that's not going to change unless today's leaders deliberately take steps to change that. So here at the Transition Accelerator, we feel very deeply about economic participation of the peoples that lived here before colonization. So consider that a land acknowledgement, and please take the time just to think about that. It's quite a remarkable thing that has happened, and we all have a chance to be part of that positive change. Okay, so with this, what we'd like to do is actually now put both Lisa and David on the spot to break from tradition and not just talk about themselves, but talk a little bit about their organization. This whole issue of solar geoengineering, I think, is a bit prickly and thorny, and it's not just technical issues. There are policy and there are legal and international diplomacy some aspects and elements. So I think having both of them talk about some of these things on the front end, almost like a 101, before we get into the panel discussion and get to your Q's and A's, is a really good thing. So Lisa, I'm going to turn the reins over to you to introduce yourself and talk a little bit about EDF and how EDF has been approaching this issue.
Sure. Thanks so much, Dan. I'm going to go ahead and share just a couple slides here to kick us off. So I'll select these, share, and then get these up to the full slideshow. Make sure that that's working. Okay. Does that look okay?
Yeah, that's great.
Awesome. Okay. So, first of all, I just wanted to start off telling you a little bit about what EDF is. It's called Environmental Defense Fund. EDF has been going for 57 years. It started in the US, but it's now basically a global organization operating in 30 different countries around the world. We have 4 core regions: US, Europe, China, and India. But we do, like I say, like work quite a broad range across the world. We have about 3.5 million members that are part of EDF, and annual revenue is about $300 million US, and about 1,000 staff. And the cool thing that I love about EDF is it really brings in the science, the economics, the business case, and really tries to look for practical solutions to whatever environmental issues that we're working on. Just a fun fact of how EDF got started. We got started from looking at the problem of birds getting killed by DDT in North America. So there was a pesticide called DDT, and it thinned the shells of birds and caused, great drop off in bird numbers. And EDF got together with scientists and lawyers and basically stopped the use of that chemical, at least in the US and other places as well. So that's kind of like our origin story. I'll just go a little bit now into where we are on working on solar radiation modification. So it can be called lots of things. I think we're calling it in this webinar solar geoengineering, also called solar radiation modification, also called different other things. EDF has actually been involved in this topic for about 15 years now. We were present at the Asilomar conference on climate intervention technologies, which at that time included carbon dioxide removal as well as solar radiation modification. And shortly after that, we launched an initiative called the Solar Radiation Management Governance Initiative with the UK Royal Society and also the Academy of Sciences for the Developing World, TWAS, in 2010. And together that was really aimed at trying to come up with a governance framework to look at how we might move this topic forward in research sense. That has since ended, that organization, and spun off basically to become Degrees. So if you've heard of this group called Degrees, it's really focusing now on building scientific capacity throughout the developing world for scientists to be studying this topic. And that's an independent organization. So that's a really successful spinoff. My boss is Chief Scientist Steve Hamburg. He was part of the first US National Academy study on this topic back in 2015. And I was part of the study that finished in 2021 on this topic. The National Academy has done a couple studies on this topic. So we've been really embedded in this topic for quite a long time in the US. We're one of the few non-governmental organizations that is really doing active things with this topic, I would say. I'll leave you with a final slide here on our program, which we've launched in the last year, which is really going beyond the governance of research, but really to have a research program itself. So we have both a research program and a policy goal in our program. It's about $6 million over a couple years. Our research program is focused on the impacts of stratospheric aerosol injection, which is a particular form of solar radiation modification. I know that David will talk more about that, but how these technologies might affect things we care about, like agriculture, water supply, ecosystems. We also have social science working in this topic. And then on our policy side, we're really advocating for additional funding for research. We're promoting discussion and dialogue around this topic. And we are also gathering other NGOs who are interested and like-minded about this to work on this topic. And not just in the US, but also in the EU, China, other places that we work. I should say also just at this time, the EDF has a statement that we do not support deployment of SRM at this time. We are solely focused on promoting research around this topic. We think it really needs to be studied more. So with that, I'll stop sharing my slides, and I think it's probably David next.
Yeah, thanks for that, Lisa. And I got to know Lisa at a workshop on SRM in Ottawa a while ago, and I was absolutely just gobsmacked to understand like the scale the Environmental Defense Fund in the States, like 1,000 people. Like everything seems oversized in the US, but that seems oversized a couple of times over, I think, for us. But
Well, and it
hey,
is global, just to be true, to be fair, we did start in the US, but we are spread around trying to spread around the world. So that 1,000 people is spread around the world.
gotcha. And Lisa, so on the last slide, you had 4 countries down at the bottom. And so those are the countries that you're engaging on this topic because they are somehow leading on the topic, or they are basically relationships that EDF has already, and you're capitalizing on those.
It has to do with our core regions
Gotcha.
already. So we have really robust programs in European Union, in China, in India, and in the US. So we're kind of starting there to focus, but
Right.
honestly, we'll speak with anyone, who is interested in moving this topic forward and moving research forward. So, I've spoken, for example, with the ARIA program, which is technically not part of the EU anymore in the UK. So,
Right.
um, happy to be having conversations wherever they might occur.
That makes sense. Okay, David, over to you.
Thank you. Thanks for doing this, Dan. Thanks very much. Good to be with both of you. So first of all, I'm the director of this Climate Systems Engineering Initiative at University of Chicago. What's that? It's a new university-wide initiative that was formed with a new president, had a committee to ask what they could really do that was different on climate change, and they came up with this, and I think in a way that was quite important to the field, not with any kind of internal advocate inside. As I think probably most of the audience will recognize, these topics have been, I think, justifiably controversial for a long time. And a lot of the university programs, like the one I helped to build at Harvard or ones at Cornell or ETH or whatever, have kind of built from one academic pushing sometimes against resistance. And what I thought was interesting at U Chicago and what made me take the job was there was really a broad decision from an inclusive committee to focus on this and try and build it as a field. So we have a license to hire roughly 10 faculty and really build this as a more substantive academic field, which in academia means a lot. And what this is for U Chicago is the overlap of climate system science, including the public policy aspects of it, and kind of older notions, partly discredited notions, I admit, of systems engineering. And the topics we're studying are solar geoengineering, the topic of today's webinar, and also open system carbon removal. So for example, adding crushed rocks to soils or the open ocean, and also some work on glacial interventions, looking in all these cases at both how these things would work, what their environmental impacts are, governance, economics, et cetera. So that's what the U Chicago program is. Now let me dive into this topic. So I think the best way to understand what sunlight reflection or solar geoengineering is in the context of what, for me, I think of as a sort of the fact that climate is fundamentally a 4-dimensional problem. So there are, this is the most basic kind of causal chain that goes from economic activities to the impacts of climate change. And there are basically 4 ways we can break this chain. The first, obviously, that we should all be familiar with is decarbonization. We can stop putting carbon dioxide in the atmosphere from economic activities by shifting to renewables or nuclear power. And I think the really good news there is this is probably the year that global emissions peak, and they'll begin to decline, and economic activity will continue to grow, and that is a big deal. It doesn't in any way solve the problem. Even getting to net zero doesn't solve the problem because emissions build up into concentrations, and it's the concentrations that cause climate change. But decarbonization is certainly the most important single thing, and I think it's important to say that there really is progress, measurable progress now in a way there wasn't a few years before. The next thing is carbon removal. So if decarbonization breaks the link between economic activity and emissions, carbon removal can break the link between emissions and concentrations. The most important kind of single thing that one should know about climate change is that the amount of climate change, the amount of warming, is roughly proportional to cumulative emissions over all time. That means if you stop emissions tomorrow or in 50 years, you stop it getting warmer, but it doesn't get cooler. And that's because basically the CO2 is built up like water in a bathtub, as we say. And carbon removal is, in a sense, a time machine. It allows us, in principle, to, once decarbonization has happened, to lower the carbon concentrations if humans want to do that, going back towards the pre-industrial, with costs and environmental impacts and complicated policy. Then the next one of these, the topic of today's webinar, is solar geoengineering, which does not break but weakens the link between concentrations, the amount of CO2 in the atmosphere, and the climate changes resulting. And then the last thing is adaptation, which again does not break, but weakens the link between climate changes and the actual impacts to humans and ecosystems. So the way I see it, there's these four kind of fundamental dimensions of climate action. Obviously, lots of different individual technologies under that, lots of individual politics under that, but these four fundamental dimensions, and solar geoengineering is one of them. And perhaps we're saying that it's not in any way new. This will be new probably to quite a few listeners of this webinar, but the ideas of what we now call solar geoengineering actually emerged at about the same time as the modern concerns about climate change in the mid-60s. So Lisa mentioned these National Academy reports. Those are very important, but there's a big treatment of what we now call solar geoengineering in the 1991 Academy report, and there were many treatments beyond that into the 60s. So this is, I haven't yet told you what this thing is. This is one picture of the various technical methods, right from the possibility of humans building some kind of shield in space that reflects some sunlight, to adding aerosols to the upper atmosphere to, again, reflect a little bit of sunlight, to reducing some thin clouds, these cirrus clouds that would change sunlight reflection, but more importantly, change the amount of infrared or heat radiation that gets out, to making low-level clouds a little brighter by putting in sea salt aerosols or making the surface brighter. I think an important thing to say maybe is how much brighter. We're talking about making the Earth of order 1% brighter to offset a big chunk of many of the climate effects, as I'll show you in a second, from accumulated greenhouse gases. I think it's important to say that it's terrifyingly easy to think of some physically plausible scheme for solar geoengineering and get it published in the peer-reviewed literature and get people to write a bunch of news stories about it. But a bunch of those schemes are utterly implausible. There's no physically plausible way we could deploy them. And I think it's fair to say, so a lot hangs on each of these words, that the only one of these methods where there is a development pathway towards deployment that doesn't depend on kind of research or some new innovation is putting sulfuric acid aerosols in the stratosphere. That's the one thing that people really know how to do. That's not saying it's a good or bad idea, but I think it's a fact that one has the technological and scientific understanding because of the enormous experience with sulfur in the stratosphere, both natural and from human causes, that we really understand how to do it in a way that none of the other ones do. All the other ones involve some kind of technology or science where there's really very deep uncertainties. So the one slide I'll show you that's kind of a positive slide is about how well these things might work. I think if you step back to 1998, I think it was, or 99, there was in hindsight, quite an important meeting about these topics in Aspen. Ken Caldera and I and a bunch of other folks were there, and somebody was pitching the idea that solar geoengineering would really just work beautifully and stupid to think about cutting emissions, and we should just use it as a way to solve our problems. And Ken and I both argued that that was crazy, and that yes, of course, putting aerosols in the stratosphere would cool the global temperature, but it would inevitably do it in a very uneven way because of the uneven radiative forcing, the uneven way that that this interacts with, say, the daily cycle or the seasonal cycle. We had a bunch of arguments. Arguments actually went back to that 1991 Academy report, really showing that it shouldn't work very well. And to Ken's immense credit, he went back to his lab and actually tried this in a climate model for the first time. And he was kind of had the intention of showing how it wouldn't work very well, but in fact found that it did work pretty well in a climate model. So now, a quarter century later, we've done this in pretty much every major climate model. And I think the results have been surprising to me anyway. I think surprising to many people. And I think it's part of what's changed attitudes about this topic is the results really look better in climate models than well, certainly than I expected. I wrote an early review article that had specific reasons why what I'm about to show you wouldn't be true, but I was wrong. So this is an example from just one particular model, a very high resolution model from GFDL, hadn't been used for this topic before, that I think does a very good job on variability of precipitation and tropical cyclones. And what we've done is we use some standard regions here from the IPCC. That's these little boxes. And in each of the boxes, we've coded 4 variables that are particularly important to human and environmental impacts. Annual average temperature is obvious. Extreme temperature is very important for both humans and environment in lots of ways. The hottest hour of the year, for example. Extreme precipitation, which in this model is the 5-day max precip, which really drives flooding risk. In the tropics, a lot of that is from tropical cyclones. And precipitation minus evaporation, which is the change in water availability, which drives ecosystems and water availability for humans. And we've coded these things. So moderated means that solar geo moved them towards the pre-industrial, and exacerbated is away. We're trying to avoid using better or worse, but effectively you could think of those as better or worse. And the big kind of stunning result here that feels too good to be true is that no region is any of the variables show statistically significant exacerbation. That is, no variables are made worse, and basically they're made better in every place. Now, not every climate model is exactly like this. Some climate models are a little bit different, but in general, this is actually a common result of many of these models. Of course, this doesn't deal with lots of other aspects like ozone layer damage or the aerosol impacts on health. I'll get to those in a second. But I think if there's a single reason to take this topic seriously, it's the set of climate model results like this that suggest that some versions of solar geoengineering really could reduce many of the climate risks that are most concerning. So there's a whole set of concerns. I'm not going to go through this whole slide, but I want to give you a sense of all the concerns that kind of are a counterpoint against that happy answer I just showed you. There's all sorts of physical risks of even well-intentioned or benevolent deployment. I just mentioned a few, but I could go on in a long, long laundry list of risks. There's different kinds of injustice. There's this concern about moral hazard, the idea that this will be exploited by fossil fuel rich nations or companies to try and avoid emissions cuts. There's a kind of collective addiction fact that it's always, if you want to slow down temperature rise the next few years, it's always way easier to do that by solar geoengineering than by cutting emissions. But then if you don't cut emissions, you keep building up the emissions problem and we walk the world off a cliff. There's worries about malevolent use. There's worries about changing the relationship between humans and nature. So there's a big set of, I think, deep concerns about these technologies. The last thing I'll say is just some idea about how they might fit together over time. So if you just did fossil fuels forever, climate risk goes to infinity. If you stop fossil fuels, bring them to zero, climate risk basically stabilize, but they don't go away. They don't get better. If you remove carbon from the atmosphere, you could, in principle, bring the climate risk back down as far as humans collectively decided to do that. But carbon removal itself is expensive and slow moving. I think, little aside, it doesn't make much sense as something that we do now. I think we should focus on cutting emissions, but it can do this different thing later, reducing concentrations, but inherently slowly. So one way to think, but there's lots of other ways to think about solar geoengineering, is it could be used to kind of slice the top off. So you could gradually start and gradually end solar geoengineering as a way to reduce the peak climate change. So the point is here, it is done as a supplement in addition to both emissions cuts, decarbonization, and also to carbon removal. That's one view of how it might be used, a common view, but not the only one. Then last slide, I would guess for many people on this webinar, and most of us think of some kind of happiness or how much we like them. We're most happy with emissions cuts and most unhappy with solar geoengineering. I think that's actually, there's sensible reasons for that preference. I think if you take the time dynamics seriously and have a kind of utilitarian view, which isn't the only way to look at things, there's rights-based ways to look at things. I think the time dimension is not what you think. The appropriate order of these things in time, I think, surprisingly, is emissions cuts and then solar geoengineering and then large-scale carbon removal later. That's because of this kind of ordering in time about cutting the top of the emissions curve off in that particular conception of how this might be done. Thanks very much for giving me the time for the intro.
David, I think that was super helpful. I think you two are the perfect guests for this webinar because you're both essentially completely balanced, no sugarcoating, but in the solution space. I mean, and why would we ignore a tool in the toolbox, at least to understand it and evaluate it to see in what conditions and what set of scenarios it could be deployed. So I think that was very useful. Look, now that we've got our intro out of the way, I'll just prompt people again to keep asking questions. And there's usually a couple of very courageous souls that break the ice, and then there's a flood of questions that come in. And I'm just going to say, Bill Lady, we've got 4 questions. Bill has asked 3 of them, so he is by far the most courageous soul. So keep those coming, folks. We've still got another 45 minutes here to get to those questions. So couple things. So let me start it off here. And there's one elephant in the room, and you've even talked about it, Dave. Like you hit it head on. Is there a risk that if we advance this technology and get comfortable with it, that it will reduce people's motivation to mitigate, to actually stop emissions? And how do you think about that? I think that's clearly what's going to be on people's minds. So look, maybe both of you to muse on that.
Oh, do you want to, should I?
Sure. Yeah.
I'll start off, and
Yeah.
then David has a lot of stuff on this too. So I think there's two ways to look at it. Some of the research that's been done amongst lay people, members of the public, asking whether just in general, when they hear about this technology, does this reduce their own personal commitment to mitigation or kind of desire to see climate mitigation happen? And the answer is most times no. They redouble effort, their thoughts to their commitment to mitigate climate change, that is to say, to deal with the emissions side of it. Personally, I think there has not been as much research done or thought given to perhaps vested interest in the system, and that they might have a different reaction than the average person you might poll in the public. So, what does this mean for vested interest, countries that might have a vested interest or companies that have a vested interest? I think they might have a different response, to that, or worry about that mitigation deterrence possibly happening. So that's what I would say, is that there's a couple ways to think about it.
I strongly agree with Lisa. There are some people who sort of advocates for this technology who will point to all these social science studies that show that exposure to information about this topic makes people more willing to mitigate, and sort of say there's no moral hazard concern. I don't agree at all. I think it's a very serious concern. I think that there are all sorts of ways in which either addiction or political exploitation feel to me likely in this context. I think if SAI gets going and there aren't obvious problems, it's one thing if it starts and there's some obvious problem, then in some sense it's somewhat self-correcting. But if it starts and there aren't obvious problems, I think it's very likely that efforts to do carbon removal are just pushed way down the road. And I think it's likely that efforts to cut emissions are slow down. And I think that's one of the sort of biggest concerns about this. I think the one thing is I don't think that's a reason not to talk about it. I think it's important to say that all sorts of environmental and social problems are solved by many different actions at once, and there's often trade-offs or substitutions between those actions or versions of moral hazard. And to me, if these technologies could really reduce harms, especially sort of to the more vulnerable people in hot countries over the next half century, I think they're worth taking seriously, even though I think there's some real risk of this kind of moral hazard effect.
David, something really jumped out at me at your intro there, and you used the phrase "drop off a cliff," and because it's not a direct trade-off, right? Am I right in sort of assuming that let's just say that we did some type of solar geoengineering, we did not reduce our emissions to the extent we wanted to. The emissions keep building up, so the problem is still there, and we're just really putting a band-aid on it with the solar geo, and that would basically make us more and more addicted to that tool because the emissions are still building up and the problem's getting worse, right? So
yeah, or
yeah.
Just a slight correction. You asked me to interrupt. It's not really emissions that build up; it's concentrations that build up.
Right,
The point is,
right.
even if you cut emissions instantly, just for the sake of argument, to half of current, like instantly halved emissions, and then left emissions at half forever, concentrations of CO2 in the atmosphere would keep building up. The underlying climate problem would keep getting worse. And if you tried to keep climate change constant, you have to keep doing more and more SAI,
Right.
which would walk the world further and further away from the pre-industrial to a more and more dangerous place, which just repeats maybe the number one scientific fact about SAI is it is not anti-CO2. You still have to get to net zero.
So that's a bit of a.
And it doesn't do it, just so we mention it for the audience, like it doesn't do anything for ocean acidification, for example, or the
Right.
kind of other consequences of that CO2, those greenhouse gases building up in the atmosphere. And the drop off could come if you stop doing this SRM very suddenly. Then people talk about the termination shock. I don't know if David I don't know if you mentioned that, but it's like again, there could be ways to not do that. Obviously, you would hope that people would not do that way, but there could be some dire scenarios where you could imagine some kind of a disaster that stops that happening. And that is a cliff then, where that suddenly all that underlying, greenhouse gas heating is suddenly revealed again to the atmosphere, basically. And we feel the effects really suddenly.
It's true that it doesn't do anything directly for ocean acidification, but it actually does help with coral reef bleaching. There's all the papers that have looked at that show that pretty sharply, because that's a combination of both CO2 concentration and temperature. And there's also this surprising way in which it helps, not a huge amount, but a little bit on CO2 concentration. So if you imagine two different worlds where you have the same human CO2 emissions, let's say both worlds get to net zero in 2070, just to pick an argument, and then are flat after that. The world where you do SAI has lower CO2 concentrations in 2100 because with the lower temperatures, you've reduced some of the feedbacks, like permafrost feedback, that would have put more carbon into the system.
Oh, sure. And the temperature, that's all the temperature effect, though. Like,
Exactly.
I mean, I'm talking strictly about the CO2
Agreed.
absorption by the ocean. Yeah.
Yep.
So a bit of a light bulb went on to me, like a strong argument around not using this as a permanent solution is because it's not a permanent solution. So
Yes.
those that basically say like we can't do this because people aren't going to reduce their emissions, and but that's not an option. So this is really, think of it more of as a temporal issue rather than a substitution for reductions. Does that make sense?
Sure. Yes. But I would say, kind of, when I teach environmental management and science, I mean, everything's temporary. People are always changing their minds about things. I mean, thinking about Lisa's introduction to EDF, one of the things I'm very proud about is my dad had a big role in DDT toxicology from Canada, and actually helped to get to, after Stockholm, was one of the people involved in the lawsuit that, or before that founded EDF. But of course, banning DDT didn't solve the problem of pesticides. The industry introduced new pesticides, which were not as bioaccumulative as DDT. Broadly, were better, but they have a whole bunch of problems that now we're dealing with in the next generation, and that's true for all sorts of things. We got rid of some ozone depleting chemicals, only introduced some other chemicals. That's the game.
Look, I think we're probably going to be a bit circuitous in this webinar here, and maybe we'll leave the technical side of things for now. We can come back to it for sure. But one thing I'm very interested in, yeah, go ahead, David. Yeah.
Really quickly, I just saw something in the chat that we probably should have said before. Somebody asked about the cost effectiveness. So
great.
we haven't mentioned this yet. The reality is that doing this is physically doing it is ridiculous. Doing it, meaning sulfuric acid in the stratosphere, is ridiculously cheap. Meaning if you wanted to ramp up to cool the Earth 0.5 degrees centigrade by kind of half a century from now, at the beginning of that ramp, spending $1 billion a year or something would be what you need to get on the ramp. And even late in the ramp, you'd only be at many billions of dollars a year, or 10, which is basically a rounding error given the amount we spend on decarbonization, which is now $2 trillion a year, or the climate damages. So, by some measures, the benefit to cost ratios are sort of 100 or 1,000 to 1.
Yeah, and that is sort of remarkable that we can't ignore that sort of, what does the tool in the toolbox look like, right? What about so where is the IPCC on this? So you talked a little bit about workshops. Essentially, what I took from both of your intros is this issue really started to come on the forefront of people thinking about it in a structured way about 15 years ago. But where's the IPCC? And of course, just for those sort of non-governance people, the IPCC, of course, is the Intergovernmental Panel on Climate Change, which is the large multi-thousand person science group that supports the United Nations for the administrations of the United Nations Framework Convention on Climate Change. So any thoughts, IPCC?
I mean, well, I'll start off. The IPCC has been pretty silent about this topic. I mean, there's been little mentions here and there. They are going to deal with it in a small way, I believe, in the next assessment. It'll be appearing in Working Group 1, which is physical science basis. I believe it'll be appearing a bit in Working Group 2, which is assessing the science of impacts and adaptation. I personally think it deserves its own assessment report. It really needs to be thoroughly assessed, all the different aspects of it. We didn't even mention this yet, but it really matters how you implement this technology. So what you do to achieve the cooling in the atmosphere. There's a lot of choices about that. So, you know, where you put aircraft on the Earth, whether you do balanced hemispheric injection, whether you how much material you put and you introduce into the atmosphere, and how efficient that turns into cooling. All of those things are sort of variables that will affect what happens in the end. And you know, these kinds, it's not like there is one it, you know, doing it is
Right.
like, there's not a single it. So, so the IPCC, I really think, could actually do a lot more to do a more thorough assessment. There was a chapter done by the WMO ozone assessment folks because of what David mentioned about the ozone depletion potential. So that has been assessed particularly in that report. But anyway, it's something I think that we would actually really benefit from, is a bigger assessment of this idea.
Building first on what Lisa just said about there's no it, I think that's really crucial to say. So if somebody tells you that solar geoengineering might have all sorts of benefits, or somebody else tells you it could destroy the world, the answer is you have no way to say that either those people are right or wrong unless you specify something about what you mean by solar geoengineering. How much is done, what method, how distributed. So there's no question that there are ways this could be implemented that would be immensely destructive. No question at all.
Right.
I think it's also true that there are ways it might be implemented that would be beneficial with relatively small and quantifiable side effects. Other people might disagree with that. But what I think we can all agree about is there's no open-ended answer to the question, what are the risks of solar geoengineering? You can only answer that with some scenario.
Sort of context.
Yeah. And to go on to IPCC, I'd say one thing I feel a little more willing to say than I would have been a decade ago is, for, I think, well-intentioned reasons, lots of senior people in the climate science and policy community, people who help to run IPCC and major journals and so on, feel that talking about this is dangerous.
Right.
And, you know, there have been strong people who believe we shouldn't publish or shouldn't talk about it. And I think that has tended to silence the assessments. So even now in the IPCC process, friends of mine who are now tightly involved with it tell me that people have explicitly told them, we don't want any positive information about SRM in there. We want to try and keep it out. And I think that's sad. It means IPCC is kind of failing in its job to do assessment. To be clear, we need politics. There might be legitimate political reasons to ban this forever. But to me, assessment ought to assess more or less what we know, and then leave politics to assess what we do about what we know. It's obviously not completely black and white. But I think what's happened is the IPCC is originally conceived, had an assessment, and then a summary for policymakers what the politics was. And now the assessment itself is really political about what's included. And this is true for publications as well. Just to give you an example, I just got a paper accepted at Nature. I'm thrilled about, second one in my career. I've never got anything in Nature from climate engineering. I'm sure I never will. We just had something rejected from Nature I think was much more important than the thing was accepted, with really elite authors, and we were basically told it was not good because it was too effective.
Yeah, I mean, you said it's sort of sad that the IPCC is doing it. I'm even going a step further. Just personally, I'll say I think it's sort of ridiculous. I mean, that's sort of an abdication of scientific responsibility when we have, you know, the scientific entity in the world that's supposed to be on top of these things, and they're saying I'm too touchy to touch. So anyway, that's you know, we try to get a little bit edgy in these webinars and a little bit truth to power. That's my edginess coming out. More might come out later. And did I hear right? There was actually like a petition that was flying around with some fairly weighty names and quite a few signatories about basically trying to build momentum against the concept or against researching the concept, or did I get that wrong? Lisa, yeah.
I think you're probably talking about the non-use agreement.
Yes, right, the non-use agreement, yeah.
Letter. Yeah, that was an effort by quite a few academics, mostly academics across the world, to put forward what they called a non-use agreement. Had several different points in there. Obviously, like non-use, like non-deployment, but also had some stipulations on research that I know my organization doesn't agree with. For example, saying that no public money should go towards researching this topic, which to my mind, that's actually the opposite. Like, I think we need more public money because public money tends to be more transparent. It tends to be, money that you can track and you can say, and you can have public input into. It tends to have review processes that are very transparent. So to my mind, it's like, if we're going to study this, we want to study this with public money, so that it's accountable to the people. So that was kind of puzzling, and I can't remember all the different stipulations, but it's definitely been, I think, kind of a negative. The overall feeling of it was that this was not something to be pursued, I guess I would say.
Well, it also has a provision saying there should be no assessment, which to me, I find hard to imagine. I got to say, I think it's a kind of degree of arrogance. You've got to be so absolutely sure in a way that I think is beyond what social science can do, that a technology is unusable or definitely harmful, to be sure that you want to actually block assessment of it. It's really quite a statement.
Yeah, I mean, the scientist in me just has a guttural reaction to that. So I think we're in violent agreement on that one. So what about the state of the research? You've both basically have said, success or a path forward that depends on putting into boundary conditions, context, and so on. And of course, that's what research is about, right? Just sort of understanding what would those boundary conditions be. So, any thoughts, or give us a little bit of a summary of your understanding what the state of the research is globally?
Yeah, I can say one important thing to say is that for at least some versions of this, like sulfur aerosols in the stratosphere, it's important to say that this isn't like some new technology. So on your webinar, you will have different times had, well, I just saw in the introduction ideas about how to deal with long distance trucking or fixed sources or all these things where there's some new technology which needs to be developed, and then you need to test the technology at scale. And it's tempting to use that frame for this topic, and I think it's inappropriate. I think there's a way in which this really isn't a new technology. It's an application of kind of existing science and technological knowledge in a new way. So I mean, humans already obviously did cool the Earth a lot with aerosols. At the peak of when we put sulfur aerosols in the lower atmosphere in the 70s, we were putting about 70 million tons a year of sulfur in the atmosphere, killing tens of million, well, 10 million-ish people with it, and cooling the atmosphere. That's why when you look at the global temperature record, temperatures don't rise despite the fact that there's increasing CO2 kind of in the 60s and 70s, and they begin to rise in the 80s, partly because that's the peak of stratospheric of sulfur emissions. And then the Clean Air Act and all the other things began to reduce sulfur emissions. We've now cut sulfur about half from the peak. So there's an immense amount of knowledge about sulfur aerosols and their environmental harms, literally of order 20,000 papers on that topic. There's 2,500 papers about stratospheric aerosols going back to the 1960s. So these are things people know a lot about. Doesn't mean they know everything. But what it to me means is that for some kinds of solar geoengineering, there's a strong basis of existing science to, not to say there's no risk, because these things absolutely do have risks, but to be able to make quantitative assessments of what the risks and harms would be. Not perfect, with uncertainty. This may be a place where Lisa and I would say it a little differently. I welcome Lisa to say it differently, but I think that's important to say. And it's also important to say that's not true about some other versions of this where we really don't have experience. So if you were doing this with a totally different particle, with diamond dust, then we really have no experience in the environmental impacts of diamond dust. And we don't really know about building structures in space.
Yeah,
Lisa,
I mean, maybe this is a good time for me to just say, I mean, we are at EDF really launching, our program is really focused on looking more into the impacts. I mean, David had a nice diagram of the global, temperature and precipitation impacts mapped out through a global model, but we're trying to kind of look more in detail about what do we know about agriculture. There might be some effects, for example, with light. When you add scattering materials to the atmosphere, you're expected to change the light profile. Does that have does that matter, for plant growth, for agriculture, et cetera? How does that matter? And then there are also some papers that really show differences in precipitation patterns and how precipitation might move around the planet. Again, it depends what scenario you're looking at for your deployment scenario. Anyway, so that's our tack is to really focus on what can we learn about impacts more specifically, because we think if this ever comes up for debate, like whether we should try to do this in reality, people are going to really care about things like in the real world. They're not going to care about average temperature or average precip even, or even at a grid box scale. They really will want to know more about what's going to happen to my region or my crops, so that kind of thing. It's hard to predict those things, I will admit right up front. I mean, those are very hard things to do scientifically. It's true for climate change in general. When you look at the impacts report, working group 2, these are hard things to look at, and we're going to try different types of tools in our program, bring in empirical data as well as modeling to try to learn what we can learn and how well we can know it for things like impacts.
Look, we can come back and dive deeper into all these things, but just to make sure, through the course of this webinar, we sort of touch all the big things. I'd like to talk a little bit about sort of the risk of Canada not being in the global conversation around risks and having some, internal technical capability to be able to engage multilaterally and so on. So, I mean, it's not the kind of thing where, but correct me if I'm wrong. So, it doesn't seem the kind of thing to me where there's a rogue state that would do this for insidious reasons, or a company would do it because there's a huge profit motivation. But there is a risk for us not being at the table talking about the implications, right? Or any jumping off point
I
there?
think there is at least some danger of a rogue state doing it. I think in practice, there's a bunch of reasons why any country that wanted to do it would probably look for a small coalition, but there's a lot of scenarios you can cook up, and we've cooked up a lot. Just to say the basics, I think there is some real possibility that over the next even decade, that this will somehow move a notch closer to reality. Maybe some country will announce something or begin something. And at that point, suddenly this will be in the middle of the political, international, formal debate around climate in a more serious way than it is now. And the Canadian government will be expected to have a position. And right now, with essentially very little research happening in Canada, and not much in Environment and Climate Change Canada or other ministries, if you were the Minister of Foreign Affairs or Environment Canada and you wanted to make a decision, be part of it, you wouldn't have much in the way of a basis to make that decision. And so one central thing that I've advocated for, and Ted Parson and I wrote an op-ed in the Globe and Mail some years ago, saying, at the minimum, Canada ought to have enough research and assessment and social science on this topic, both in academia, in civil society, and in government, that if that day happens, or when that day happens, I think it's more likely that those government officials would at least have something to turn to in terms of Canadian expertise and people they could talk to who are engaged.
Lisa, how well do you think the U.S. is sort of positioned for that?
Well, the U.S. is having its issues right now in terms of
We never noticed. We never that's.
Lisa, I probably said this to you before, but there was a Canadian podcast by the Globe and Mail, one of our leading newspapers, that talked about the problems down south as the crack house downstairs. And I say that with citizenship in both countries.
Yeah, it's really tough right now for science in general in the U.S. There actually has been for several years now a dedicated research program in the federal government that is looking specifically at how you monitor the stratosphere to look for evidence if somebody were to, for example, deploy this. How well do we do at monitoring the stratosphere? And there have been some other studies that have been funded through that pot of money. There have been some privately funded research programs. EDF is funded through private philanthropy. There's much, like I think we were speaking before this started about the UK program, that UK has just launched a giant program at about, I think it's about 70 million US dollars total, really launching into all kinds of aspects of research in this topic, including small outdoor experiments, which are the most controversial part of this, of the research landscape of this. So, but I would say, I was on a committee a few years ago, and we did a sort of back of the envelope estimate of launching a research program. What would it take? I think we came up with $100 or $100 million a year to try to just start at some of the questions. And, obviously we're nowhere near that in the US anyway, and it's unclear how the programs will continue going forward. But there have been research programs in China before. I don't think they're continuing right now. Australia has a research program using a different, not SAI, but looking at marine cloud brightening types of techniques over the Great Barrier Reef. So there is, there are little pockets of research going on around the world, but it's not really, it's a very small amount, I would say, of overall climate research going on right now.
Right. I think I just saw in the chat someone had put in that a couple of state legislatures have legislation in front of them now that would ban this kind of research again, which is quite
30, at
striking.
least 30.
Yeah, a lot of legislatures in the
Good
states.
God.
Yeah.
Yeah.
Wow.
Yeah.
I mean, it's just like, I mean, we have the whole contrail whack job right up here thinking that that's the US government sort of seeding this or that, but that sort of, to me, takes it to the whole level, and that's legitimate. 30 state legislatures, crazy. It might be the crackdown south, or it could be the ketamine.
It's not just down south.
So-
Daniel Smith, the premier of my province, answered a question in a manner much the way RFK Jr. did, basically accepting, I forget the exact wording, but accepting that chemtrails were a thing and need to be investigated.
And then not all the bans are succeeding, just to say
Sure.
that
Yeah, that makes
sometimes they're getting proposed, but they're not actually passing and things like that. And
Yeah.
they've all got their own quirks about exactly what's said about them and things like that. But it just shows, I mean, I feel like having legitimate research programs in the public eye that are saying what's happening, saying what's doing, that's actually going to benefit public knowledge about what this is and what it isn't, but maybe I'm an idealist in that sense.
I am too. There was a question in the chat asking how we deal with it. Two things to say. One is I really commend to you the work of Holly Jean Buck, and particularly a piece she has on conspiratorial environmentalism. I think is really superb, and I think she's interviewed lots of people who hold these beliefs, and I think has a really thoughtful way to understand how these fit into a set of different beliefs of what she calls para-environmentalism. And I think the only thing I can say is A, I don't know what to do, and B, it's not ignorable. That is, I think at
Right.
this point, these topics are big enough and broad enough that the belief in these conspiracy theories that they will shape the way this topic rolls out, whether we like it or not. I mean, way back, I think I was involved in the first public perception survey that asked about this with Ashley Mercer, who now works at NRCan. And even back then, this is about 15 years ago, we asked a version of, do you believe government is doing the secret thing? I forget the exact wording. And there was sort of 10% of people, and that was a UK, US, and Canada survey.
David, about 10 minutes ago in the chat, you shared a link to papers. And if that paper you just referenced, would that be available at that link? Or
No, that
you did
paper I
not-
just referenced is by Holly Jean. So the paper, the thing I shared is my own papers. Sorry for the egotism. Holly's paper on, so she doesn't like the title. It's called "The Rise of Green MAGA" is easy to find.
Okay, the rise of green.
I think Michael Thompson just provided a link in the.
Okay,
in the
very
chat.
good. Well,
Yeah.
that's great. Very predictably, of course, the question floodgates have opened, and we're sort of sorting through these folks in real time here. There's a few early on, and now we're sort of getting back into the digging deeper into aspects of this. Several questions dealt with this idea of like, can we learn anything from volcanic eruptions or some type of natural perturbation about what an artificial perturbation would look like? Anything thoughts on that, folks?
For sure. I mean, volcanoes form sulfuric acid aerosols in the stratosphere. They've been studied in detail. Volcanoes have been observed to cool the. I mean, we know they cool the Earth. It's a really
Right.
basic piece of climate science, undisputed. There are ways in which volcanoes are kind of unlike SAI, both in terms of the size of the aerosols, which matters for a bunch of techie reasons I won't get into, and the fact that it's a pulse that turns on and off. So that tends to mean that you cool the land more than the ocean, because the ocean has heat capacity, and that tends to reduce monsoons. And that wouldn't happen in the same way for SAI that was continuous. But there's certainly a lot you can learn, but it's not just volcanoes. Of course, there's a background flux of sulfur into the stratosphere from little critters that live in the ocean that make something called DMS. And there's also all the sulfur pollution we put into the atmosphere that there's been an immense amount of studies on its climate impact. So there's a lot of different ways in which there's existing science.
Yeah, and people have also studied the ship track, the natural
Yep.
experiment from
Yep.
there was a pollution reduction measure that went into effect, I believe, in 2020 that reduced pollution from shipping, and
Yeah.
you can actually see the signature of that the cooling that was caused by the kind of dusty, the aerosol filled smoke, that reduced, and you actually get a small heating, and it's debated like how much that effect actually is. but that's another kind of analog, natural analog, like a volcano. Some people are looking at things even like wildfire smoke. If you had wildfire smoke
Right.
in the air for a long time, say a season or something, like, could you look at any kind of signature from that? I mean, the reason we want to look at natural analogs like volcanoes or these other sources of particles in the atmosphere is because it's really hard to do experiments in the atmosphere on this. It's been tough to do. And so the more we can actually learn from natural, events or natural kinds of analogs, the more informed we can be. And as David said, though, of course, a single pulse volcano is not the same as an interhemispheric, like parallel deployment in the North and the South Hemisphere that would be carried out through aircraft in a certain for a certain length of time, for an ongoing length of time. So there's a lot of things to learn, and I think even our models honestly are not perfect at predicting what is going to happen with this. We'd get a lot of our information from models right now, but they are not actually perfect instruments for looking at this problem particularly. They weren't designed for it. So not to say, I mean, we use the tools we have, but there's lots of things to still learn, I think, about the effects of this.
And so we've talked a lot about sort of research and the need for research. So if you're not in the conversation globally, by definition, you're going to get left behind. David, your answer to this notion of there might not be, I couldn't see a sort of a commercial motivation or a rogue state, but you're thinking, well, there sort of could be, right? I mean, there's lots of interest want to keep emitting, and it's not that much money in the big picture. So like there are, security risks and so on associated with this. So if either of you had a blank sheet of paper and X amount of dollars, that's sort of a big question, but what would the research look like? Like, what do you think we should be doing from here on?
Hmm. I think one of the biggest challenges is actually trusted assessments. I think for sulfuric acid in the stratosphere, where there is this strong background of knowledge, I think there's a lot of research you can do, and I'll talk about that in a second. But I think the biggest thing is actually developing more trusted assessments, back to this problem of IPCC or some other agency, because nobody can or should believe what just one or a few scientists say, especially people who specialize in a topic. I think I only trust things more where there's some really robust assessment process. I also think we need something that, not to use, well, to use a military metaphor, but not for a military thing, a kind of red team, blue team analysis, where I think it's important that actually some proponents of this put forward a relatively clear, specific plan of how it could work, and then have a really structured, careful critique of the ways it could go wrong and what the uncertainties are. So those are some kind of structured things I need. And then there's a giant list of research from a whole bunch of ways to improve the modeling of aerosol sizes in the stratosphere, to looking much harder at what the high consequence, low probability outcomes are, not what most climate models say, but what the climate model's worst case is about SRM.
Right.
And then there's a bunch of ways that you could do experiments in the atmosphere that would teach you little bits of science that would improve the models.
Lisa,
Yeah,
what's your
and I would add to that, like, I mean, obviously I've spoken about, I think, the importance of impacts research, and it's, I think we need to think of impacts research as not a prediction, like that's going to be what happens, but how well do we know what we think we know about this? And I appreciate so much David's long history of this research, but we need more, more of that kind of looking at how well do we understand. I mean, temperatures are that's a pretty solid one, I think. Precip, I have a little bit more questions about. Like, precip's not done as well by the global models. I think it's the water models, there's not a single water model that's the same as another water model. So, I think there's a lot of room for that. I think we haven't really mentioned research on geopolitical risks, or,
right?
how you might compensate people who say that they're going to have harms, or are we going to even try to be attributing, like, if we get into the world where this is being done, what happens if a country says, well, we're suffered harm from somebody doing, from
Right.
our world doing geoengineering? Like, do we have a way to detect and attribute and say that that's actually the case? And at what lag time? Like, some of these effects are short term, they happen in the near term. Some things you might not detect for years. You might not see impacts from it and be able to discern the signal for a long time. So I think that's the kind of research I'm really interested in too, is like how to know what you know and how well, and whether you can actually answer questions that people might have imagining that this is actually being deployed. So a lot of the geopolitical, like other kinds of questions about that.
I mean, I'm getting sort of techie into experimental design here, but like David, your answer was like a lot more upfront on the concept of assessments. Like there's nothing to disagree, like that's seems almost self-evident. And
Well, but I mean, yes, but clearly not. The fact is, I think
you're
I
right.
went to, or actually, I was leaving the Calgary airport and United was down. That there was a 3 working group meeting in Lima, Peru, about how to organize IPCC around solar geo. I think 15 years ago. It was back when I was a U Calgary
Right.
professor. And the point is, we've talked about doing assessments
Sure.
for a really long time, and we've utterly failed.
Yeah, so I get that. Yeah, but
Yeah.
like that's and it's no risk, right? I mean, this is just a paper exercise, right? So that's like,
Yeah.
like why not? Let's just do it. Then there's the modeling, which is that's the major tools that we have. But what would you say to skeptics that would say, I'll even set this up a little bit. I remember one of the coolest cartoons I've ever seen, like not on TV, but a written cartoon was a sketch of the globe, planet Earth. And then underneath it, it says n equals 1. DF, degrees of freedom, for you stats folks, equals 0, meaning like we've only got one of these. So what would you say to people that say, look, you can do all the assessments, you can do your modeling, but at the end of the day, it's really difficult to figure out how this is going to play out in the real world. Like, is there any thoughts of sort of experimental design to do it sort of small scale, phased, regional something, and what that would look like for? Because I think that's at the heart of a lot of people's discomfort here is like, we've only got sort of one crack at this because we've only got one world. And is that actually true or not? Or is there ways that we could sort of manage that risk?
I think it is an underlying and sensible concern. I think one thing important to say is this is inherently something you can ramp up and down.
Right.
So,
Okay.
so one thing one could do is ramp it up to say something of order 100,000 tons a year of sulfur in the stratosphere, which is about as much as the background natural flux from DMS. That's enough to already stop 1 year of warming, roughly. It's enough to really perturb the stratosphere. It's actually a factor of 2 perturbation of the natural stratosphere. So you'd learn a huge amount about stratospheric circulation and so on. And yet, it's almost impossible to imagine there's a big risk from that. Because to give you context, that's 0.1 million tons. The Pinatubo volcano put 8 million tons, so it's 80 times less than Pinatubo. And we observed Pinatubo and lots of other volcanoes. And we were putting 70 million tons in the lower atmosphere. And once the sulfur comes in the lower atmosphere, it just doesn't matter where it started, more or less. So I think it'd be very hard to argue there's a big unknown from doing that. And you'd learn a lot. And yet there's no danger of lock-in because it would be immeasurable to turn that off. So I think there's versions of that you could do. Essentially, you could start and then make decisions about ramping up. But even here, I'm falling into you. Obviously, we live in a divided world. There's no one decision maker, nor should there be one decision maker. This will be a complicated collective decision. I think the one thing that is lucky is that there aren't very many knobs. There's really the most important one, Lisa already referred to, is this hemispherical balancing. But other than that, for stratospheric aerosols, they just last for 2 years. You can't have them just over one place. And in some ways, that makes the politics both harder and easier in complicated ways.
Lisa, anything to add to that?
No, I think that's right. I think the challenge is, yeah, it's like we talked about experiments too in our report, and kind of minimal amounts of material that could be, I think the key thing is being able to learn something scientifically from the experiment, which obviously any good scientist is doing, right, is trying to do that. But these are the most controversial aspects of this topic. It is very tough. I know if, David was, intimately involved with one of the research experiments, but there have been others as well that just have not gone forward in actual execution. And so I think that's something we have to ponder as a community if we do want to do experiments, is to think about how they can be done in a way that the people around the experiments, the public, the people that might be affected, even, I mean, there's not necessarily much physical risk for some of this, but there's other things people care about than physical risk as well. People care about, well, what does this mean? What does this imply about what we're doing? Is this a slippery slope towards deployment? Those are the kinds of concerns I think that people have. And those need to be, I think, met head on with respect, of how do we actually respect those concerns and argue for the value of learning more about the system. And it may be that people decide, no, this is not something we want to do or learn more about. That could be a perfectly valid outcome of that kind of engagement. But it is, I think this is the kind of work that is the way you have to go with research experiments, typically.
Two comments. First, on the question that we didn't quite go to, if there's only n equals 1, there's only one planet. I think that's complicated and cuts both ways. There's really a risk-risk trade-off. So if you imagine a world of 2050 or 2070, to make it binary, of course it's not binary, but there's a world where we have however much CO2 is in the atmosphere from, we cut emissions pretty well, but not perfectly. We've got the CO2 in the atmosphere, we've got the warming. There's a world with that amount of CO2 in the atmosphere and we suffer the consequences. Or that amount of CO2 and some SAI, and that means less overall warming, which has a bunch of benefits, but then we've got this additional risk from SAI. And there's a clear risk, and we only get to do it once. And that's true for lots of things that humans do, in fact. So there's no version of this that's risk-free. On the other hand, it's by no means clear that this increases the risk, because a lot of climate risks increase with the amount of climate change. And if SAI reduces climate change, it reduces some of the nonlinearities and uncertainties of climate change, but then it introduces its own. So it's complicated. On the experiments, let me just say that at least some of the experiments, like the one that I was involved in, Scopex, I've been involved in some others, had a negligible risk other than like the balloon falling on somebody. And that was interestingly true, even to their great credit, of the Sami Council, this indigenous group in northern Finland. Their letter that killed that experiment because of the reaction of the Swedish government, their letter freely conceded that the experiment posed no physical risk, and they just said the whole idea of solar geoengineering was wrong, so research should be forbidden or shouldn't be pursued. And that's a totally legitimate thing for them to say. I think my answer is, in a democracy, we need to have governments form processes that reach democratic decisions about what kind of research we should do.
I think of research in Canada here, scientists will follow the money, right? So we've got sort of a couple of major sources. One is line departments, and the other is sort of like SRC, or the NRC, sorry. And then we've got, of course, our granting councils here as well. I mean, it would seem to me that of the three buckets we've sort of landed on, like what would you do next, is the assessments, then there's the modeling, and then there's actually physical research. And as scientists, this is Dan talking here, not even the accelerator, but as scientists, and I think we tend to convince ourselves that we are always objective, and we have this utterly emotionless rationality about how we think and so on. And of course, often, especially collectively, nothing could be further from the truth. I wonder if there's a way to try to advance the whole file by unpacking those three actions, three separate things, instead of saying, like, let's do number one, like right now in Canada, an assessment. Let's start planning for what the best approach to the modeling would be, and those would get us closer to some type of physical validation verification or something like that. I don't know, was that a useful way to think about this?
Yeah, I mean, I think I don't think I or any other scientists believe they're coldly objective and purely so. I'm certainly not. I think that's why you should never trust any one person, and that's the good thing about research that funds a range of different people. And I think just starting some research, I mean, there's a tiny bit of research, but just increasing the amount of research groups in Canada funded, making sure that some groups that are funded that have a pretty critical view of this idea, that's to me the way to get started.
This is a pregnant pause, Lisa. See if you've got anything to add, yeah?
I was just going to add, I mean, I am not from Canada, and I don't know all of the issues in Canada, but it's really interesting to me. I mean, Canada has several aspects of its country that it's going to be really important for them to know, what is this technology? Is it going to help or not? Because you have lots of ice covered area, right? That is potentially it is melting. I'm sure now you've got a lot of risk and vulnerability to climate change, and I mean, knowing more, I guess, from your own country's perspective, what would happen, or, is this something that you think is good or bad from the Canadian point of view? I mean, research is important for understanding that more. I mean, we had a workshop there in Canada a couple of months ago, and on the street, I was like talking to other folks about, okay, well, how fast could this stop ice from melting, or could this refreeze the ice that's being lost, or is this going to help Native peoples in particular places? Like, I don't think that that's a given, that it's like, I mean, I think we need to understand, what to expect, what to promise people from this technology. And it is not just a reverse back climate change technology. It does have, as David said very well, it's temperature is its big thing, and that will be huge for affecting climate change. But it's like creating a third state of the climate. It's not a reverse back. There are additional pieces to it that make it a novel climate, basically. So I think that it is worth studying, and I mean, we work with Degrees, which is a group that really advocates for countries throughout the developing world to develop their own capacity in understanding this and doing research on this. And so, and the mantra there is, people need to have their own scientific expertise to weigh in on this when, when push comes to shove and it gets debated. And I think that's probably true for Canada too. I mean, you obviously have David's, and you have several actually excellent Canadian scientists that will serve that purpose for you. But I just feel like it doesn't seem like it's going away. This is my feeling is it doesn't seem like this is going away. This is something that, as climate change accelerates, there's going to be more push to try to go and use this. And so understanding more about it is, I think, going to be helpful and useful. I don't believe that it actually pushes us towards using it. I think it actually helps us understand it more. That's at least my feeling about doing research on this.
Lisa, that was a great, I would say, final statement in our dying minute here. David, if we turn to you just for 30 seconds, what do you think Canada should do next steps on this?
I think the things you said, start some kind of assessment process, and most of all, start a real research effort. And as Lisa pointed out, there's, by chance, several of the researchers in the world have published the most on this topic. Ted Parson and Doug McMartin and me, and a couple others, but those are all Canadians, even though our jobs aren't in Canada. And so there's lots of place to start, and there's some Canadian researchers who are already working on this. So I think the key thing is this doesn't cost much money. So Canada, even though it's small, could actually do a lot, could be a leader on this if it wanted to be. And I think, given the dumpster fire in the US, I think it's really important for other Western democracies, not just, also in the developing world, to begin to get serious about this. So we don't just have the US voice. And so I care about that both as a Canadian, but also sort of global citizen. I think it's important to have voices other than the US that have some kind of knowledge and power and stake in the game. And I'd like to see Canada do that.
Well said, both of you. And that, folks, takes us to time. I'm going to thank the audience. Thank you so much for, we know there's lots of competition for podcasts and webinars and so on. So thanks for thinking this was a good use of your time. I'm going to do a very quick shout out to Sarah Catherine, who has been the person that developed this webinar series and does all the framing and all the behind the scenes organization with Viola's help. She's starting on mat leave in about 2 weeks. We're going to lose her for a year, but thank you for all your help, SK, and we'll see you in a year. Viola will take over. And thanks to David and Lisa. I learned a lot. I'm sure everyone did. And folks, feel free to connect with each other based on who you saw was in the chat. We've kept track of the questions and look forward to thinking and talking more about the concept of solar geo going forward. Thanks to both of you.
Thanks for having me.
Thank you.